In this scenario, we need to set up our linear equations by looking through each statement and try and translate the statements from English to mathematics, basically. And so I see here the first statement that a movie theater has a seating capacity of 261. That can't be immediately translated into an equation, so we read on and see that the theater charges 5 for children, 7 for students, 12 for adults. So right away now we can start putting little pieces together. And we begin by assigning variables. And I'm just going to use obvious letters like C for children, S for students, and A for adults. And then we'll go ahead and use those to set up our equations. So the first equation comes from this statement, the first statement about seating capacity. Now, seating capacity should be an inequality, right? Because that capacity is the at most situation. So what we want to say, what we should say is C plus S plus A, that's the total number of children, students, and adults, should be at most 261. But for the sake of being linear equations, let's go ahead and put that at equals to get the theater at capacity. And then we also know that this quantity is going to give us the quantity for the charges for the tickets are going to end up giving us another equation later on. We read on and we see that there are half as many adults as there are children. Now, this one is a tricky one to set up. You just have to be mindful of the English doesn't directly translate. So, for example, and this is how I'd work it out, for real, is by saying, okay, if I have half as many adults as there are children, if I had 10 children, so if that's how many children, how many adults would I have? Well, you know that it would be 5, right? So you have to see how C and A relate to each other. And you can see that A, I'll write it as A. If I set up A, you can see it's half of C. Or another way to see that is that C is twice A, which I like better because there's no fractions. So again, taking this statement right here and rewriting it in mathematics really requires you to set it up in terms of relating the quantities to one another. How, if like there was 10 children, how many adults, and just working that idea out. Okay, so I'm going to go ahead and get rid of all these, like the work to get to that point, but be mindful that there is work involved and that you have to put it together. Okay, next bit is the next phrase. Total ticket sales were 1886. And so we go back to the statement about how much they charge per children, per student, per adult. And you see that we can say, well, if we do 5 for every child, plus 7 for every student, plus 12 for every adult, we get the amount 1886. And so that's our setup. And then we use all of our tools to be able to solve this system. And there are different ways to do it, and we can use a very simple way of, one by one taking, okay, for example, this line will allow us to replace, with every time we see a C, we're going to replace it with 2A. Okay, so let's go ahead and rewrite this equation. And we're going to, like the first equation, we'll start with the first equation. We can replace C with 2A and observe that if we do that, we get 2A and then another A here. That gives us 3A. So our first equation becomes 3A plus S is 261. And then we do the same thing in our third equation that we have here. So again, replacing C with 2A, that's going to become, right here, this is all going to become 10A. And then if that's 10A, do the scratch here, and we have a 12A over here, that's going to give us a total of 22A. So we're going to have 22A plus 7S equals 1886. So our first and third equation are there now, and so we can actually get rid of those. We've kind of replaced them with our equations. I'm going to leave this up here because, we used it, but we didn't replace it, right? So we replaced first and third with using that second equation. And now we go ahead and, okay, this is another good one where we have it in one single variable S. We can solve it for S, then plug in that quantity for S in the third equation here, and solve for A. That's the approach that we're going to take. So the first equation becomes S equals 261 minus 3A, and then we're going to take the S in this equation right here and plug in that quantity, 261 minus 3A, for it, and we get 22A plus 7 times 261 minus 3A equals 1886. Right? And finally, we have an equation here where it's all in A. Right? It's one equation, all in one variable. So we just solve for A, and we're done. And so we just go ahead and solve for, gather all our terms, and we have, you see here, let's see, we have 22A here, and then the 7 has to distribute. So we're going to get, let's rewrite this equation. This becomes 22A plus, 7 times 261. I should have my calculator out, but I don't have it out. So 7, and then 42, and then 18. So this is 1827, and then minus 21A equals 1886, and now that simplifies. 22A minus 21A is just A, and then we'll bring this over, and we'll have 1886 minus 1827, and I believe that's 59. So that's our first result, is that A is 59. Let me write that here. So that should be 59. Okay, maybe I'll move that over. Whoops. A is 59. Okay, and actually, since we have what A is, notice here we have that C is twice A. So actually we can get C. And I'm going to get rid of a lot of this. Is a little bit busy up in here, so let me get rid of some of this scratch work here. Okay, whoop, I shouldn't have erased that S. There's an S that goes here. So if A is 59, C is twice A, that means that C is twice 59, which is like 2 times 60, which 120, and then you subtract 2. 120 minus 2 is 118. So, oops. So from this equation we get 118 for children. All right. And then the last bit is how many students. And we go ahead and plug in 59 for A in there. And that's 3 times 59. That's like 3 times 60. And then you subtract 3, right? So 3 times 60 is 180. And then subtract 3, that's 177. So Over here we get 177. All right, and that's how, oh, no, we don't get 177. That's just what 3 times A is. So that goes here, and then we get 261 minus 177. There we go. And you subtract, let's see, and you get 84. So you actually get 84 for students. Okay, good. All right. And that's, well, that should answer the question. So you go back into the problem and you say, okay, well, the first problem was if I add all these up, do I get, okay, let me see. If I add all these up, do I get 261? And then you just check to see that that's the case. 118 plus 84 plus 59. Let's add all that up. 8 plus 4 is 12, plus 9 is 21. So far so good, because I want that 1 in the ones place. 2 plus 8 is 10, plus 6 is 16, and then 261. Yay! And so when you know that one of them is correct, you know, you're kind of like pretty sure that the rest of it would be. And that's how this works.